Hi boys, this is the third example of check yourself 2. Okay, first step, h prime of x, and we have here 1. It will be 1 minus, okay, root x we can write as a x to the power of 1 over 2 prime. It is equal to 1 minus 1 over 2 multiplied by x to the power of negative 1 over 2. And it is equal to 1 subtract 1 over 2 multiplied by 1 over and square root x. And we have as 1 minus 1 over 2 root x. So let's join this. It means you can join by finding common denominator. You multiply by 2 root x. 2, that's a 2. And we have here 2 root x. Subtract 1. Okay, that's our f prime equation. The next is equalize with 0, and we have here 2 root x subtract 1 over 2 root x, that's equal to 0. Okay, since this is a rational expression, a rational function, from the 8th grade we can understand that we can write numerator function and denominator function equalize with 0. It will be 2 root x minus 1, that's equal to 0, and 2 root x is equal to 1. Root x is equal to 1 over 2. Both sides take to the square, like this, and we get x that's equal to 1 over 4. That's the first critical point. And the root x is not equal to 0. Why? Because it is in the denominator, and it means if you put here 0, it will be 0 all, but you can divide this by 0, so you write as 2 root x not equal to 0, root x is not equal to 0, and x is not equal to 0. From the theorem of critical points, we can say that this is also critical points. These two are critical points. Critical points. And you need to understand, can you use this 0 and solutions, next solutions, or not? I can say that you can use this 0. Why? You need to understand or repeat the presentation again. Okay. The next step is putting these critical points instead of h of x. Okay, h of x is equal to x subtract root x. Okay, the first of h of 1 over 4. Okay, here you have 1 over 4 minus in the square root of 1 over 4. It is equal to 1 over 4 subtract 1 over 2. Okay, the common denominator is a 4. 1 minus 2. And is equal to negative 1 over 4. The next is h of 0. It's equal to 0. Subtracting square root 0 is equal to 0. Okay. The third step is finding h of 1 and of 4. H of x is equal to x subtract root x. And then in interval of 1 and of 4. Okay, let's divide by 2. H of 1 we have 1 subtract root 1. It is equal to 1 minus 1 is equal to 0. H of 4 it is equal to 4 subtract square root 4, or it is equal to 4 minus 2, it is equal to 2. Now we have 4 answers. That's the first answer is negative 1 over 4, h of 1 over 4, h of 1 over 4, sorry, h of 1 over 4, it is equal to negative 1 over 4, h of 0, it is equal to 0, yes, and h of 1 we have 0 again, and h of 4 we have 2. Yes, now we need to understand which one of them absolute maximum, absolute minimum. From these 4 we can say that this is h maximum, because 2 is the biggest number, so it is. But what about minimum? You see we have negative and the 0. The smallest of course is 0. Why not negative 1 over 4? Why not this? Because it is negative 1 over 4 is less than 0. If you want to find the answer why is h of minimum is 0, why it is not negative 1 over 4? Okay, let's come back to our function. Our function is of h of x is x subtract negative root x. Subtract root x. From this expression we can understand our domain. Domain must be even to all positive real numbers. Means all numbers that are start from 0, including to positive infinitive. Why not 0? Because if you put here negative 1 over 4, for example, you'll write like this, h of negative 1 over 4, you will get expression negative 1 over 4, subtract and square root negative 4. You see that your even numbered root is your your root are square root, it is even. You can put here negative numbers, so we are excluded these meanings and we have 0 and 2.